Hello, welcome everybody today. So we have today the second day of this amazing summit, and we are going to talk today. Yesterday we talked more about the framework, about the internal of the XGLs, and the different pieces that we have. But today we are going to focus more on the solutions and the things that can be built together with deck.gl and also with other platforms. This talk, I would like to explain to you how CARTO is working together with deck.gl in order to provide a platform to develop geospatial applications and how we are trying to modernize that part to reduce, and mostly the main focus is try to reduce those development times when you are developing a geospatial application. So one thing that we know that developing a geospatial application is hard. We have improved a lot during the last few years, but if we gave a step back, um, there are some different areas of work. The first one is base maps that I think that we have improved that part a lot during the last few years with Google Maps, with Map Libre, Mapbox, Azure Mars, Amazon Locations, etc. and Esri. And the other point is to create advanced mapping visualization. And I think that that is the part that this year has covered super good. So we have been able to improve this with all the layers catalog because I think that is what people really like about DeckGL, a part of other things that we will cover later. But there is still a few things that are not trivial and are areas of work, and this is where CARTO try to help. This is like visualizing large data sets, millions of polygons or billion of points that can be doing with open source, can be doing with other platforms, but it's not simple. And it's required advanced backend skills to develop that things. The other thing is data engineering. When you are dealing with large data sets too, and you need to move, you need to gather your data, you need to figure it out how are your zip code layers, where are your block group layers, or any other data, and also you need to create ETLs to move the data between your platform, the geospatial platform, and so on. And the other point is spatial analytics. We have, when you are building an application, sometimes you require a very small things or a very complex one to do geospatial analytics to analyze and to share this data with the users of your application. I think that deck.gl plays an important role because the people who is developing this thing really like deck.gl. And they like, I think, that in first point because they like the powerful visualization capabilities of deck.gl. Also, they like the pricing that is open source and they can use for free. For small projects is a very nice thing. And also for large ones. And the other thing that they like is open source and open governance. When you are developing an application, you are very worried about the stack that you are using because you are going to be tied to that library for so long. And that's part of the open government and the last movement. I think that is part of the success of the growth of DexGR during the last few years. The high quality of the product is also something very important. The modular architecture that you can import wherever you want, but at the same time, the projects can work and can expand a lot. And also that is a reactive paradigm, but it's also possible to develop with other frameworks. That if you are using Angular, you can still use DexGL. If you are using Vue, you can still use DexGL. That is customizable, and there is not a huge learning curve for developers. And I'm going to try to explain how we are trying to improve that at CARTO. Basically, what we want is we are using a cloud native approach that we connect where your data warehouse is, and using a SQL approach, you can develop your application. So we remove a lot of work on the backend side. And we also avoid things like need to create ETLs because we are going just to the data warehouse where the data is. And also make easier your spatial analysis with a drag and drop tool. This is the different parts that we covered before, the visualizing large data sets. CARTO offered the Maps API that offer dynamic tiling for medium data sets that you do in real time, and also tile sets for large data sets. For data engineering, we offer two things. That is Data Observatory, that is a huge geospatial catalog where you can connect to your data and get a subscription of your data, and you have that directly in your data warehouse, and then for creating different ETLs. And for spatial analytics, we offer spatial analytics also inside of the data warehouse of the user with drag and drop. Let's see DAX in action. I'm going to try to follow a small process starting from something simpler to become more and more complex when you are developing a tool. The first thing, imagine that we have for an application a classic data set where you have the stores and you have the revenues of those stores. And you have those data, in this case, for instance, in BigQuery. So the first thing is that how we can visualize this thing. Let's go here and yeah, I think that let me do a little bit bigger. And it's pretty simple. In this case, you need to go to CARTO, create an API key, put your credentials, and you only need to put the connection that you are using, the type of map that you are creating, in this case is a table, and the name of the table. And directly CARTO provide a backend to provide this and to work with this data set. But what happens is, for example, we want to create something a little bit more complicated, that we want to get the revenue of these stores by states. So CARTO provide in the data observatory this layer of states, of zip codes. Imagine that you want to join this data with a boundary. With this example of the states, so you can use SQL and you can filter the data using SQL, and you can create this query to join the revenue of each of your stores and using SQL Analytics to create these final maps. This allows you to do different kind of operation. In this case, what we are doing is getting all the points that are inside of an state. We are grouped by all of them, and then we sum the total revenue. We can also support these different parameters that you can say, for instance, hey, I want to filter in other month, and it should work in the same way. If you are using a state, probably it's not so useful, because you could have a very basic filter in JavaScript. But what happens if we are dealing with, for instance, with zip codes? In this case, with zip codes, it's a little bit more complicated, because the data you cannot have on your client side in JavaScript all the data of the revenue for all of your zip codes. That becomes more and more complicated. But in this case, it's exactly the same. We just change the table of the boundary, and we can still use SQL to provide this data to the user. So with just having a table and with just a few lines of code, you can start creating different KPIs and different type of maps directly without required to develop backends and required to develop the rest of the things. Now let's see another example that is also very useful. That is loading or not? Yes, it is. That CARTO can also allow you to aggregate the data using H3 indices. So what we can do is to say, hey, let's calculate what is the H3 index of each store, and let's group by that H3 indices, and then let's calculate that aggregation. The powerful thing here is that CARTO is not working with the standard geometries. We are working, in this case, with H3 indices. It is extremely fast when you are facing with those databases. We are going to see an example later where we can visualize table up to 60 million rows in real time and doing a specific queries with BigQuery, because those data warehouse, when they need to work with numbers, they are extremely fast. And here exactly the same thing apply, that you can apply different filter. I don't include here the query parameters in this example, but that was a matter of using is something common in all the cases. So let's start now with this quite analysis of coverage and overlap. As last year, I did that example last year in the previous summit, and at that time the difference, and what I want to tell you today is that how CARTO have improved this part. Because last year we need to do that, all this analysis in SQL, but today we have this other tool. Let's first, we have CARTO workflow, that is what we are going to find. But first, let's try to understand what is this analysis. The coverage is mostly that, imagine that you have your stores and you want to know how much population, how many persons are affected in the area of interest of your stores. In other words, it's like how many how many people can you reach? And here for calculating this is like you have the difference point that you will see in red, and then you have the area of interest of every single store. And you need to calculate all the population that belongs in all of these areas. For overlap analysis, it's just to calculate the areas where you have more than one store covering. So it means that there is one person in this area that can go to multiple stores. Let's try to shoot as samples. Using, in this case, we are using what we as CARTO workflows. That is a low-code geospatial analytics platform that using drag and drop, you can create this analysis. Let me do this a little bit bigger. Here it is. Okay. This problem is a typical problem that solving with classic geometries will be super painful. But using H3, we can simplify this problem a lot. The first step is that we calculate the area of interest of each store. The area of interest, in this case, I use a buffer, but you can use also an isochrone that using third-party provider. CARTO also offer those components. And the first thing is that you can create a buffer, for instance. No, it's missing. So the first thing is that you say, hey, I want to calculate a buffer that is 2 kilometers away of my stores. Then, after that, the next operation that we do is a polyfill of all the buffer that we have. This polyfill, we decided to say, hey, okay, I'm going to do that at resolution 8 of H3. You can do whatever that you want, but in this case, for this analysis, I think that H3, analyzing my data, is a resolution that makes sense. And then, after that, you can start calculating the overlap and the coverage. Let's start with the coverage, for instance. Calculating the coverage is super simple. It's just remove duplicates on your S3 cells, and you will have all the S3 cells that are in the area of interest of your store. Once you have that, we join against a data set of of data observatory that is a data set of spatial features, and this data set of spatial features can join directly with the S3 indexes. This data set is a data set that our data team have prepared from CARTO, and you have in S3 level different data like populations in different ranges, number of POIs, number of restaurants, and things like that. So the first thing is that we calculate the cells that are unique. Then we join with the spatial filters, and that is a very simple join using an H3 column because we have all the data in H3. And then we save the result like a table. And we are going to see finally that map. And we can visualize what is the coverage of population. For calculating the overlap is quite simple too. That is like a way of, in this case, what we do is to first, let's group by to count how many cells are repeated. If you have 2 cells, that means that there are 2 stores in there. If you have 4 cells, that means that there are 4 stores overlapping. In this case, we do that, and then we apply the filter. In this filter, we say, hey, we are calculating the overlap, but with a value of 4. That means that is overlapping 4 stores in that specific region. And then we join again to the population data sets, and get the data with using a very simple join. If we go here, I think that I have lost my internet because nothing is charging. Previous example was loading 1 second. It's working now. Let me reload this too, because load like for whatever reason. But here it is. In the right side of the map, we have the places where we have overlaps between our stores, and in this case is the map of population that we are covering. So that is like this analysis was super complicated. For example, CARTO was developing this at the very beginning with standard geometries, using unions, using intersect, and this is super hard because you need to compute all the intersections between different data sets. And that is a huge in terms of computing. We were doing this for Renault, that's for the automotive company, that they are doing analysis for opening new outlets and so on. Okay, so let's jump to the other things. That is how CARTO can help to visualize large data sets. The first thing is that imagine that you have here it is. We have in BigQuery, we have all the data of OpenStreetMap. So imagine that you have a huge data set. In this case, I am using one for OpenStreetMap, and you want to visualize. This is a data set with all the buildings of the world, and so visualizing that is not an easy task. So the first thing is that we create this table and extracting this from the data from OpenStreetMap. And the next point is that CARTO offer inside of your data warehouse, also in SQL, the ability to create a tile set with those buildings. So with this specific query, you produce another table that is this one, that is a tile set with your data. And then you can go here and you can visualize all of the buildings. And let me check our real examples. Here it is. Mm. And here we are. And you can see that everything is super smooth, visualizing this huge data set. We can move around. Yep, it's working super fast. It's trying to move to the other tab, but I don't know. 1 second. Okay. Another thing is that visualizing very large data sets with H3. In this case, we are visualizing a table of 6 million rows, and it's using the same approach. The same approach with dynamic tiling. In this case, we are not using a tile set, so we can run dynamic queries against our H3 table, and you can just visualize that directly. Other things is this thing that we include this year is raster support. So imagine that you have a raster, and what we do is to convert this raster to a cloud-native geotiff. And imagine that you have a cog raster, though, or you have a standard geotiff. We convert to a cloud-optimized version, and then we upload that inside of a table in BigQuery. Inside of that table, we have a very efficient data structure to be able to visualize that directly, and also to apply different analytics operation using directly the BigQuery for assessing the data. So in this case, we have a raster of temperature. We built this for the demo that we did for 3D tiles with Google Maps, and you can visualize that in deck.gl. And this example is how you can, for example, get the value of a raster in a full table inside of BigQuery. So you can have your table, and you can ask, hey, I want to get a single value in a single point, or you can project the value of the raster in another table of geometries, and do different analytics operations with this. That is one part. And the other, how we are using generative AI. That is something that has been uh, with ours during the last few months a lot. And how CARTO is doing this. And the idea is that right now we are doing this um, using geospatial prompt engineering. At the end of the day, is how to know how to ask for that specific models. What I have to say is that we don't have almost anything production ready because it's super complicated to do these things and it's not still stable enough. But I would like to explain more or less how we are doing this, just in case that would be useful for others. This case that is like one of the things that is interesting is to provide automatic generation of labels for different models. So the good thing is that giving a prompt of test and giving some prompt of engineering, you can use that in geospatial, using in this case these specific values that I say, hey, give me a set of parameters for a particular location in the city. And then you will receive that a human description of that specific area. And that is very powerful because you can use that for that purpose. And that is like, hey, air quality, house price, crime rate, amenity, and a school quality. That can give to you that is like, this is very good because of air quality, but it have high house prices, and that can be very interesting to open this for generation. The other is that we use that to basically generate sequels. We have different proof of concepts. So one of the things is that these large language models have been trained with a lot of data that is in internet. And one of the things that we have also in BigQuery is the field data of OpenStreetMap. So with that information, you can create things like that. You can say, hey, give me give me in this case all the point feature that is like healthcare facilities in the south of Spain, or give me health facilities. And take a look on all of this happening here. First thing that they are is look like it is able to provide you a bounding box with the area that you are describing directly. And the other is that he is also available and he's also can understand that he's using a feature type of points and things like that. So is able to generate this kind of queries. Unfortunately, as the test and the prompt is quite open, is not working in the 100% of cases, and that is why we don't have all of this in production. But it's extremely useful, and I think that we are not investing more on this because we think the main cloud vendors they are going to progress more on these areas, and that is makes more sense to wait a little bit to those platforms evolve a little bit and then to continue on doing that integration. Like in this case, it's like, hey, we created this small plugin that from SQL, in BigQuery you have remote functions that you can call to external functions in other places. So here in this case, we have an external function that's called to OpenAI, or it's also possible in BigQuery to call those language models directly from SQL when you're using Palm, uh, and that can provide you this final map. And I say that is like the percentage of where it works is like 2 or 4 times. One every two, it's worse. The other not. It gives an error because the sequel is not correct and so on. But I think that this part will improve a lot in the future. And that's all. So thank you very much. And now open for questions.